The sink is clogged. Now what?
Pouring caustic soda!
But why does caustic soda unclog a sink? To explain that, today I came to Unipar's Cubato facility, where they produce, among many other things, caustic soda. Caustic soda, also known as sodium hydroxide, is a very strong base. In chemistry, bases are the opposite of acids. For example, vinegar, lemon, and soda are acids. On the other hand, substances like bleach, soap, and shampoo are bases. In a sink, what usually causes the clog is grease, and caustic soda reacts with that grease. And here's something interesting: the word soda actually comes from sodium, which is part of the caustic soda molecule. We also have something else in our kitchen that contains sodium table salt, which we chemically call sodium chloride. If both contain sodium, wouldn't table salt also work to unclog the sink? After all, isn't the sodium what's making the difference here? Caustic soda and table salt are related, but probably not in the way you're thinking. So let's do an experiment. We built a kind of sink simulator here, which we're going to clog with a bit of grace. On one side, I'm going to add water with table salt, water with sodium chloride. On the other side, we'll add water with caustic soda, the famous sodium hydroxide, the star of our video. Let's clog the pipes. The texture is kind of weird, but it smells good. See, the water doesn't pass through. In this first sink basin, I'm going to add 3 tablespoons of caustic soda, which is exactly what the package recommends for unclogging a sink. And on the other side, 3 tablespoons of table salt. To finish, half a liter of water on each side. And as you can see, nothing is leaking. Now, let's wait. There wasn't even time to film it. It took 3 minutes. I was sure this would take a few hours. The grease broke down and the sink unclogged. There's still a little bit of grease left here, so I'll do it again so you can see what happens. Now, did you see that? The pipe with caustic soda cleared in, I don't know, 2 or 3 minutes, where we used salt water. It made no difference at all. We could stay here for hours, days, even years, and nothing would happen. The difference in how sodium acts when we use table salt versus caustic soda lies in the molecules themselves. Here at Unipar, their job is precisely to reorganize these molecules to produce chlorine, hydrogen gas, caustic soda, and polyvinyl chloride. And it all starts with purified brine, which is basically water with salt. Caustic soda is produced through electrolysis, a process in which electrical energy drives a non-spontaneous chemical reaction. Electrolysis takes place in a container called an electrolytic cell. And here at Unipar, they use cells with plastic membranes. We're inside a warehouse with uninstalled cells, and we can also see them being assembled in the workshop. Yes, you can see it. Each cell has 2 parts: the anode, which is the positive pole, and the cathode, the negative pole. Electricity passes through the liquid between them, which is the brine. To understand how a cell like this works, imagine a box filled with salt water, but with a divider in the middle, a membrane. On one side, there's a positive pole, and on the other side, a negative pole. These are the electrodes, and electricity flows between them. On the positive side, chlorine gas forms. This chlorine comes from the salt molecule placed there, which is NaC, At the same time, the sodium, the Na, moves to the other side, crossing the membrane. On the negative side, hydrogen gas is formed. This hydrogen comes from the water, and at the same time, some hydroxide from the water molecule is left behind. This hydroxide then combines with Na, which is sodium, forming sodium hydroxide, which is caustic soda. Okay, but why is this membrane necessary? Its role is to ensure that only sodium ions can pass from one side to the other. Brine can't pass through, and neither can any gases. That's important because during the chemical reaction, we don't want everything mixing randomly. Everything has to be well organized to ensure only the desired results. The thing is, for all of this to work, we need an electric current of 17,000 amperes. That's about 1,500 times more than the maximum current a household outlet can handle. Looking inside the cell, besides the membrane, the entire positive part is made of titanium, and the negative part is made of pure nickel. This here is the heart of the factory. This is where the electrolyzers are, and where the cells will be installed. It's really cool to visit a construction site, because we get access to things we normally wouldn't, like this. Here we can see the copper bars that will carry the electrical energy. Look at how thick they are. Each electrolyzer has more than 200 cells. Considering the entire warehouse, we'll have almost 1,300. At Unipar, membrane cells are central to Cubito's technological upgrade, making it the largest facility in South America. Using this technology, they use energy much more efficiently than other electrolysis methods. One of those other methods is the mercury cell. In that case, the metal combines with sodium and then goes to a decomposer to separate the elements and only then produce caustic soda. Another technology is the diaphragm cell, which works as a physical barrier. Similar to the membrane, the diaphragm, however, is less selective than the membrane. It ends up allowing some ions to pass through, which makes the caustic soda solution more diluted. Membrane cells also take up less space. We replace a huge box like that with a slice like this. Each slice is a cell where electrolysis is taking place. The membrane acts as a physical filter, but unlike ordinary filters that block by size, it can also block based on electric charge or chemical affinity, which is how strongly substances are attracted to each other. Membranes are also used in wastewater treatment, water desalination, batteries, and even in hemodialysis. Each application requires a different material, highly specialized plastics, ceramics, and more. All of this is designed based on how particles, which are extremely tiny, interact with the material. That's why we call this nanotechnology. When we work with things much smaller than a millimeter, it's considered a technology of the future because it makes processes cleaner, more efficient, and more sustainable, saves energy, and enables things that were previously impossible. Why did the caustic soda unclog the sink and the salt didn't? Caustic soda reacts with fat in a type of chemical reaction we call saponification. You might think that means the formation of frogs. No. In this case, it actually means the formation of soap. In fact, we've already made homemade soap twice here on Manual do Mundo. And you know, it takes oil or fat and caustic soda. The part of the caustic soda that really makes the difference here is this. It's the hydroxyl. This hydroxide that is released when it dissolves in water that breaks down the fat. Then we get the formation of soap and glycerin, which are substances that dissolve in water. The sink drain can then carry them away. Table salt doesn't have a hydroxyl group. Instead, it contains chlorine. By watching the video, you saw that table salt is closely related to caustic soda. That's because the sodium in caustic soda originally comes from table salt in the industrial process, and the hydroxide comes from water. So we can say that caustic soda comes from table salt and water. Here's an important warning. Using caustic soda to unclog sinks is very common, but when it's diluted in water, it releases heat, which can deform your pipes or even make the clog worse. You might replace a grease clog with a soap clog. That said, there are many other situations where caustic soda is extremely important, such as in the production of soap and detergent. It's also used in paper production to make it whiter and more uniform. And in food processing to alter texture and acidity. In preserved olives, for example, it reduces bitterness. And I came to Unipar to share these curiosities with you and show the modernization of the Cubato plant, which demonstrates how one of the world's largest producers of caustic soda and chlorine is committed to improving its processes and producing more and more while using less and less energy.